Is now starting. All attendees are in listen-only mode.
Welcome everyone. Just give it one more minute before we start to allow for people to join. Okay, everybody, we might begin today's webinar. Thank you all for joining us today for our SEED webinar series on energy efficient cooling. My name is Emily McQualter and I work for the Energy Efficiency Division of the International Energy Agency. I'm joined today by my colleague Joanne Dundon, who is managing the technical component of our webinar today.
Hello everybody, nice to have you with us and we hope that you enjoyed today's webinar. Sorry for the slight delay in starting.
In today's webinar, we are linking with the IEA's Energy Efficient End Use Equipment 4E Technology Collaboration Program, who have put together an excellent panel of experts to discuss new developments in the testing of inverter air conditioner performance and the relationship to government policy in the United States, Canada and Europe. The webinar will examine findings from a recent 4E report that highlights the need to address potential issues in current testing practices for inverter-based technologies, which are experiencing rapid growth in many parts of the world. The webinar today will be moderated by John Simbowski. John is the Program Manager for the Appliance and Equipment Standards at the US Department of Energy, which sets the test procedures and minimum energy performance standards of over 70 products. John is also the current Vice Chair of the 4E TCP and heads 4E projects on air conditioners. We also welcome other guest speakers today: Jessica DeWitt, Burley Bearlatz, Kimberly Curran, Catherine Revest, and Rusty Thorpe. Their interventions will be followed by an opportunity for you, our audience, to express your opinions or raise questions during our Q&A session. In addition, if you would like to ask the speakers any questions as the webinar goes along, please use the chat box that you can see in your control panel. My colleague Mark Ellis from 4E and myself will be monitoring this. The webinar will be recorded and will be available online, and we'll be sending you an email after the webinar with the link to the recording and the slides. Before I hand over to John, I'd like to provide you with a brief overview of the Super Efficient Equipment and Appliance Deployment SEED initiative and also 4E. The SEED initiative brings together 18 member countries, partners, and a broad community of stakeholders to create opportunities to share experiences and learnings on the development of measures to stimulate the development and the deployment of energy efficient products. It is an initiative under the Clean Energy Ministerial that the IEA is coordinating. The webinar today forms part of our webinar series on cooling. Within SEED, we cover a full range of equipment and appliances. We're in the process of exploring opportunities to do further webinar series focusing on other product categories. So if you have any suggestions for webinars, please also send them through in the chat box. Currently, SEED is in the process of a redesign, which we started when the IEA took over the coordination of the initiative late last year. We have a lot of ideas which could be used to develop a vibrant community of best practice and provide opportunities for knowledge sharing. And again, we welcome your views and suggestions. Now moving on to the 4E TCP. It's one of the IEA's 38 TCPs that bring together governments, industry and other stakeholders to undertake a joint research and development across a range of technologies. 4E's main areas of work focus on electric motor systems, solid-state lighting, electronic devices and networks, power electronics and converter technology. And across these product categories, they also work on 4 themes of standardization, capacity building, including within laboratories, innovation, monitoring, verification, and enforcement. 4E has been in existence since 2008 and focus on supporting the development of policies for energy efficient equipment amongst its 15 member governments. Its members tend to be governments with mature energy efficient product policies, and 4E works closely within the IEA Secretariat and many other intergovernmental organisations with shared aims, including SEED. So that really brings me to the end of my introduction. It's now my pleasure to hand over to John to moderate the webinar and to start our discussion on test methods for residential air conditioners.
Okay, great. Thank you, Emily, for that great introduction, and thank you, IEA, for giving 4E a chance to promote what we feel is a very, very excellent product on the topic at hand, which is the residential test methods for air conditioners. Today we have, as Emily said, brought together a number of experts from around the world to discuss air conditioning in their home areas, plus areas of interest to them. And so if you move to the next slide, you can see why we think air conditioning is important to talk about, not only because it's a very warm day here in Washington, D.C., but because of this chart. And so this is something we picked up from an IEA report, but you could see the projections of the air conditioning stock globally through 2050. Clearly an area of growth, clearly an area of increasing energy use, and clearly an area where policymakers need to focus on in terms of energy efficiency if they'd like to keep the energy use in check as this end use grows over time. On the next slide, you could see that in the US, we're a little bit different than the rest of the world in terms of the type of equipment we use to meet our cooling demands. And so I won't go into the detail here, but there are several different types of technologies that are employed depending on the building type, the region of the country, et cetera, et cetera. Now, when we embarked on this particular project, inverter technology is what's being employed mostly around the world. And if you move to the next slide, why it's important to the US, while we're starting at a small base here, you could see 7% in 2017. Just over the next handful of years, this number is going to increase, we think, by 35% or so. And then in the future, continuing that trend. So, so why test methods? You know, we focus a lot on MEPS and minimum performance standards, but unless you can really measure the energy use accurately and have harmonized metrics around the world, since this is a global technology, we feel there could be some market confusion and some outcomes that may or may not be desired based on the fact that the test methods are not measuring things the way we think they are. So with that as a backdrop, I'm keeping my introduction short and let the experts really talk about the heart of the matter. And I will be back later towards the end of the program to do the Q&A, but I will now turn it over to Jessica DeWitt, who's with the Cadeo Group. Jessica and her company were the prime consultants to write this study for 4E. And so Jessica, it's my pleasure to turn it over to you.
Thanks, John. Hello, everyone. As John said, my name is Jessica DeWitt. I'm a mechanical engineer with the CADEO Group. Today I'm presenting findings from a study conducted for IEA 4E last year on test standards and harmonization of domestic air conditioners. Go ahead and go to the next slide, please. This research was really conducted because test procedures are foundational to national energy efficiency programs. The goal of the research was to compare international air conditioner test procedures and identify key areas where test procedures could be improved or better harmonized internationally. Harmonization of these test procedures can reduce test burden, share best practices internationally, and allow for better comparison of equipment across countries. And so all of that put together, CADEO partnered with STEM Integration Services to review and compare a selection of international test methodologies for domestic air conditioners designed to provide cooling or heating and cooling. Next slide. This research began with review and comparison of the test procedures shown in the table here, with a primary focus on comparing the scope of the products in each test procedure, the test methods allowed or required, the secondary energy uses tested, and the ability of each test procedure to rate fixed and variable capacity equipment. The research team found that scope varies between test procedures, with the overlap focused on ductless split system air conditioning equipment. Most of the test procedures that we reviewed allowed 2 test methods for measuring performance, with only 1 country requiring a single test method. All of the test procedures rated some form of secondary energy use, although there was variation on what form of secondary use was measured. And all the test procedures had a method for testing and rating both fixed and variable capacity equipment, but there was variation on test conditions at part load operation. Next slide. So in addition to looking at the test procedures directly, the research team also investigated energy efficiency metrics used by each country, with an emphasis on how test conditions impact the efficiency metrics. And the team found that while most countries use some form of seasonal energy efficiency metric, specifics on how these were calculated and the test conditions at which they were measured vary between countries. Namely, seasonal metrics rely on multiple temperatures. There's test condition temperatures and there's local climate rating temperatures. So looking first at the test condition temperatures, we found that the high temperature test condition is nearly fully aligned across all the test procedures that we looked at. So there's harmonization there. There is some variation of low temperature test conditions. And one observation that our team made was that in some cases, the seasonal energy use calculation or metric calculation extrapolated performance beyond the low temperature test condition, which can be less accurate than an interpolated performance. We also found that seasonal energy efficiencies are rated based on local climate conditions. And since local climates vary, these seasonal metric temperatures are not standardized and should not be. To support that, we found that regional weighted seasonal metric temperatures don't appear to directly correlate to seasonal energy efficiency rating temperatures. Next slide. So the team used these findings from the test procedure and energy efficiency metric review to develop recommendations for international harmonization and improvement of air conditioner test procedures. We found that standardization of low temperature test conditions represent an opportunity for harmonization. They may also help seasonal efficiency metrics be more relatable between countries and minimize extrapolation of load curve during seasonal efficiency calculation. We also found that standardizing secondary energy uses should be considered. This would result in more comprehensive and consistent assessment of energy performance. And some other opportunities for harmonization we identified were standardizing refrigerant line length and charge, and also standardizing equipment nomenclature and terms so that everyone is speaking the same language. Next slide. As an opportunity for improvement, the team found that while all countries include variable capacity testing, approaches could be improved to better characterize performance, especially at part load conditions. Current test procedures fix compressor speed at part load condition. This doesn't accurately represent how these systems operate in the field. Load-based test procedures have been developed to dynamically test variable capacity equipment in some countries. There are questions about ensuring the reproducibility of results from these test procedures. And also, current seasonal efficiency calculations vary between fixing a degradation coefficient and measuring it. And we found that accurately characterizing this is important for correctly anticipating seasonal efficiency of variable capacity equipment. Next slide. So in summary, this research scope reviewed test procedures from 6 countries in addition to the international standard. We found that the test procedures are generally aligned, but there are some opportunities for harmonization of test methods. There's also an opportunity to improve testing of variable capacity equipment. We found that improved harmonization can reduce test burden, share best practices internationally, and allow for better comparison of equipment across countries. And there are some next steps planned for this research to further evaluate test methodologies for variable speed air conditioners and heat pumps. And that completes my summary.
Okay. Thank you, Jessica. And
Yeah.
So next we're going to move on to some regional reporting out. And I believe our next speaker had some difficulties connecting. Virlay, did you get on?
Oh, unfortunately, sorry, this is Joanne
Yes.
here behind the.
Hello?
Oh,
Can you
Virlay, are
hear
you
me?
here? Are you
Yeah,
here,
I just
Virlay?
sent an. Yes, I'm
Oh,
here.
fantastic.
Just in time.
Sorry,
Great.
this is wonderful.
Yes.
All right.
Great news. Let me
You
bring
made
up your
it.
presentation.
Okay.
Made it at the last second. Okay, so
Yeah.
so it's my pleasure to introduce Virlay Berlax from the European Commission. She's going to speak on sort of the EU perspective and the testing that they've done here and plans for her future. So over to you, Virlay.
Thank you, John. Hello, good afternoon, everyone. So please go to the first slide. Yes. So I'm going to talk a bit about our experience, our recent experience during the review of our regulations for residential air conditioners. So residential air conditioners and heat pumps are included in our eco-design and energy labeling framework. The eco-design framework sets minimum energy efficiency requirements to these air conditioners and heat pumps, which means that products which do not meet those minimum requirements can no longer be placed on the market. In addition to that, under the energy labeling framework regulation, these products also have to bear an energy label. This energy label informs the consumer about high efficient appliances, and in doing so, we hope that consumer will choose these high efficient appliances. Next slide, please. Yes, these measures are currently under review. Next slide, please. So the energy efficiency requirements in the regulations are set according to the seasonal energy efficiency values. In Europe, we test these values according to the European standard EN 14A25. The energy efficiency values are representative of a cooling season and a heating season, so not one heating temperature, one ambient temperature, but arranged throughout the whole cooling and heating season. In principle, this European standard uses the same basic principles as the ISO standard for seasonal efficiency. Next slide, please. However, during the review of our regulations, some stakeholders have raised concerns with the current testing method. The first concern was regarding thermal comfort. So it was seen by a stakeholder who did some calculations and testing that about 45% of the units in cooling mode do not dehumidify during testing. And of course, dehumidification is really necessary if you want to ensure a thermal comfort. In addition to that, in the heating mode, it was seen that during the test in a lab, the air that blows out of a heat pump was as low sometimes as 27 degrees Celsius and commonly lower than 32 degrees Celsius. The problem with this is that temperatures that low will not give a sentiment of comfort. As such, we think that the temperatures that blow out of a heat pump should not be below 32 degrees and probably even closer to 40 degrees to ensure the thermal comfort. In reality, if a unit would really work in these conditions, so not dehumidifying and blowing temperatures as low as the ones that are used during test, the end user will probably change the set point of the appliance, which will increase the cooling and the heating loads, and in reality will lead to lower real-life performances. Next slide, please. A second concern that was raised was exactly that the current test method requires manufacturers to give the settings of the unit during test for any type of market surveillance testing. In doing so, the test bypasses the controls of the unit and it locks the compressor during test. In principle, this is a worldwide practice and it gives very robust results, but the performance of units in real life may differ from the performances measured in test conditions. Next slide, please. So since this initial discussion, which dates from, let's say, September of 2019, we've been looking for solutions. So the first solution for ensuring thermal comfort, we are looking to set some parameters to make sure that thermal comfort is ensured. So in heating, we would set parameters, for example, the airflow rate, such that the temperature blowing out of the heat pump is between 32 degrees Celsius and 40 degrees Celsius. The exact temperature at which we will set these parameters will depend on further discussions. So we just had a working group meeting on the 18th of June, and we're now waiting for further input from stakeholders. So it's really a discussion that is ongoing right now. In the cooling mode, we would also set parameters, and here we were thinking about a maximum sensible heat ratio or a limitation as well on the airflow rate. And there were two proposals. One proposal was from a stakeholder, which said that the minimum sensible heat ratio should be at a maximum of 70% at 35 ambient temperature and 95% at 30 degrees Celsius. Or alternative, and this comes from the AHRI 1230 standard for VRF units. It would be a minimum sensible heat ratio of 80% at 5 degrees ambient temperature and 85% at 30 degrees Celsius. Again, here we're just at the start of this discussion, so probably alternative proposals will be given by stakeholders. This is not at all final, but we're in the middle of discussions. Next slide, please. So the second part of the solution is for the testing method. So an alternative testing method to the one that fixes the compressors, requires the settings of the units and bypasses the control. Here we have two alternative methods that have been proposed by stakeholders. The first one is the compensation method. This compensation method sets a thermal load to which the machine has to react. The unit has to maintain a certain set point, the compressor and the outdoor fan are unlocked, and it is the control that controls the unit. So it is more according to the real life. The test conditions are the same as what we usually use, so the European standard of 14825. The issue with this method is, I mean, the method has been established, it is written down in the standard, but we do not have any round-robin test results, so we don't have a clear idea on how accurate, reproducible, and so on the method is. So right now, a round-robin test is ongoing in cooling mode. For heating mode, some tests have already been done, but more tests might be needed before we can use the method for regulatory purposes. An alternative solution to this, and this was proposed by a stakeholder as an improvement to the compensation method, would be the same. So the thermal loads would be imposed to the machine, the unit has to maintain a certain set point, and the compressor and fans are unlocked, and the control makes sure that the unit reacts to these to the load. Here, instead of a limited number of test conditions, there would be 21 steps of 2.5 hours covering the whole load that the air conditioner has to go through. But unfortunately here, the method needs a bit more work even than the compensation method. So probably we cannot use the method at this point right now. Next slide, please. We have been discussing proposals to move forward. So as I said in the beginning, we are reviewing the regulation. We are planning to publish a revised regulation, and a proposal that we are now discussing, so a possible way forward would be so to have a two-tier approach. In the first tier, we would make sure that thermal comfort is ensured, so by setting some parameters to make sure that dehumidification occurs during cooling, and that the temperature that blows out of the heat pump is at a comfortable temperature, and that would be in the first tier. So setting requirements to make sure that the heat pumps in testing conditions have to comply with a certain level of thermal comfort. Then we would have a second tier, which would be much later than the first tier, and this is to give manufacturers the time to keep on working on this alternate, well, the manufacturers, but also the test houses and some of member states that are involved. It would give them the time to finalize the round-robin testing, and it would also give time to set out the method in the EN 14825, or at least an improved method in the EN 14825, which is our European standard. But from a date which is tentatively mid-2027, there would be a mandatory application of an independent testing method that does not fit the compressor and the fans, and which fulfills the requirements for a method fit for regulatory purposes, which means that it would be robust enough to have reproducible results and accurate results. The regulation in total would then be reviewed again after 7 years to check whether everything goes smoothly and to check whether any additional improvements are necessary. This is it from my side. Thank you very much. Looking forward to further discussions.
Okay, thank you, Veerle. That was excellent. I think that presentation dovetails very nicely into, I think, Catherine's presentation's up next from the US perspective. Yes, and so from the US perspective, we've done some recent work here as well, and I'm going to turn it over to Catherine Revest, who's on my team here in the US DOE, to talk about the VRF test procedure developments. Catherine.
Thanks, John. That's right. Today I'm going to be talking to you all about the ongoing developments with the commercial variable refrigerant flow test procedure. So this rulemaking is still ongoing. However, the negotiation associated with this rule has concluded, and I wanted to share with you all the recommended approach that was born out of the negotiation. So to give a little bit of background here, our current federal standards and test procedures for VRFs are based on EER, which is a full load steady state metric. Now, given that all VRFs are variable speeds, there was interest to modify the federal test procedure to one that accounts for that efficiency benefit of variable speed technology. So at DOE, we have a process by which recommendations for energy efficiency standards and test procedures can be negotiated amongst stakeholders. So this VRF test procedure working group included manufacturers, utilities, efficiency advocates, and consumer advocates, all with different opinions on how to actually modify the current test procedure in order for it to be representative, reproducible, and not unduly burdensome. So the starting positions of the working group members were generally split into two categories. There were those that supported a dynamic load test and those that supported a part load IER metric, which is comprised of 4 steady state tests at different load points. And the issues that we ran into during the negotiations were similar to the issues outlined in the research report that Jessica outlined this morning, along with Veerle, about the testing of variable speed units. So for instance, the proponents of the dynamic test felt that it would be most representative of field conditions. They had reservations about the IER metric due to the fact that testing required operating the unit in the lab in a manner that's different than it would be operated in the field. Whereas those that supported the part load steady state metric had reservations about the potential burden and possibly the lack of reproducibility of a dynamic test. So fast forward well over a year of negotiations, of testing programs, of evaluating different testing approaches, and what was forged was a solution that addressed the major concerns of each group. So the consensus position that was ultimately reached is effectively a middle ground approach. It included a steady state part load IER metric with the inclusion of something we call the Controls Verification Procedure, or CVP for short. Next slide, please. So as was described earlier, the modulating components within a variable speed unit are programmed to continually adjust in response to the condition of the space. Now, in order to be able to perform a steady state test, that programming has to be overridden and the unit has to be forced into a testing mode. So examples of some of the critical parameters that might need to be overridden to perform a steady state test would be the compressor speeds, the fan speeds, and the valve position. So in the controls verification procedure, the unit is operated dynamically under its own native controls without any of the critical parameters being overridden. The indoor room temperature is gradually decreased in a ramping procedure that passes through the VRF set point. And then those critical parameters are monitored throughout the duration of the CVP. And then the average values of those critical parameters are calculated for a shorter increment in time. And those feed into the steady state test. Next slide, please. So the purpose of the CVP is to determine how the unit responds dynamically under its own native controls through the observation of those critical parameters. And then that system behavior acts as boundaries to the steady state test. So the CVP isn't intended to quantify the performance or the efficiency at any test condition. What it does is ensure that the efficiency values that are being generated in the steady state test are more in line with what you would expect to see in the field when the unit is operating dynamically under its own native controls. So this is just a high-level explanation of the resolution the working group came to, which is essentially connecting both dynamic and steady state tests to reach what was deemed to be an acceptable balance of representativeness, of reproducibility, and burden. So this approach could be applied to other types of variable speed equipment. This is commercial equipment, but it addresses the same issues that have been brought up for the residential sector as well. So as I mentioned before, we're still in the process of the rulemaking, so please stay tuned to the VRF test procedure docket to see more specifics regarding the actual implementation, but this is, as I said, an overview. And that concludes my slide, so I can pass it back over to John.
Okay, thank you, Catherine. And as Catherine said, you know, that is still being worked on, and my understanding is all of the work that's been done there is going to be rolled into the most recent version of AHRI 1230, which is being close to final any day now, so hopefully. Anyway, with that, I will turn it over to our final speaker in the country updates, and that's Kim Curran from Natural Resources Canada. She's going to give us a little talk on what Canada's doing in this area. Over to you, Kim.
Thanks very much, John. And thanks to the organizers of this webinar and to all of the speakers so far. I've really enjoyed hearing what your work is doing. And I do think, as John said earlier, these discussions are dovetailing very well together. I hope everyone out there is keeping well and staying safe. I'm pleased to have the opportunity today to share with you Canada's perspective on this important topic, and to highlight some of the work we're doing to learn more about variable capacity units and how they can contribute to actual energy savings for Canada and beyond. Next slide, please. So today I'll be sharing some information on Canada's policy context under the Pan-Canadian Framework, regional considerations that play an important role in our approach, and I'll highlight some work that we have underway. Next slide, please. Under Canada's climate change goals for the reduction of GHG emissions by the year 2030, the Pan-Canadian Framework sets out a number of initiatives, including 5 areas for work related to energy efficiency. Work to understand the role of variable capacity air conditioners and heat pumps fits under the Build Smart building strategy, which is on the far left of the slide. Next slide, please. To help us focus on where we can make the most difference in the building stock, we can see from the graphic on the left that space heating represents the lion's share of energy use in buildings, which is, for Canada, about 40 times that of the cooling demand. So I think our perspective becomes a little different, although the machinery is the same, and this is where I think we can contribute to the conversation. On the right side of this slide, you can see in terms of emissions as well, given that we are operating under the Pan-Canadian Framework, that space heating represents about half of the roughly 60 megatons of emissions associated with energy use in the residential stock in Canada in 2017. Next slide, please. To help transform Canada's energy profile, including for space heating, our group in the Office of Energy Efficiency takes a 3-pronged approach, similar to what we saw in Verly's slide. First, our regulated requirements eliminate the worst performers based on a cost-benefit approach. Second, working with the US EPA under an agreement, Canada administers the voluntary Energy Star program in Canada to promote high-efficiency products through product certification and labeling to increase consumer awareness. And finally, Canada is in the early stages of implementing a national market transformation roadmap, which focuses on ways to make technologies more accessible and available, and to increase awareness and acceptance. This roadmap sets out aspirational goals. These are targets, not requirements, for space heating, water heating, and windows. Climate plays a big role when considering how to advance these aspirational goals. Looks like we're having some slide issues. So I'll just keep going. Currently, about 2/3 of Canadian buildings use natural gas and propane to space heating, with the remaining third of building stock heated by electricity, biomass, and fuel oil. To address gas heating, Canada's regulated energy performance standards for gas-fired furnaces were published in 2019, setting efficiency requirements at condensing levels or best in class. Electric systems are generally radiant baseboard systems in Canada, with only about 10% of electrically heated homes using heat pumps. So there's still a great opportunity for us to further improve the installed stock by focusing on heat pump technologies for space heating. See, we landed perfectly back to where we were. That's great. Thank you. So this slide tells you what many of you already know. Even using averages, there are very wide seasonal temperature ranges for Canada in the range of more than 60 degrees Celsius swings, and that's average temperatures in some areas of Canada. And conditions are regularly in the minus 30 degrees Celsius range for a large part of the population during winter months. So for Canada, space heating solutions, cold conditions do matter a lot to us. And to further complicate things, across the country, we have 6 different climate zones that span these regions. So a one-size-fits-all approach doesn't work too well for us. We want to be sure that we understand the issues. Next slide, please. Yeah, so these are the 6 climate zones. Next slide, please. Further, while Canada enjoys a very low emitting electricity generation grid overall, there are variations by region for now until the regulatory requirements for coal-fired electricity generation kick in the year 2030, when the overall grid intensity will be even more favorable at less than 100 tons of CO2 per gigawatt hour, which is extremely low. Next slide, please. Work done a couple of years back by our CanMet Energy Labs at Natural Resources Canada has confirmed that energy costs in these various regions do also play a big role in the technology selection for heating. So cold climate heat pumps can be cost effective and can save energy in the near term to lower emissions from space heating of some Canadian homes. The biggest opportunities are in replacements of oil furnaces and electric space heating applications. But for the lion's share of space heating in Canada served by cheap natural gas in regions where it's available, more work is required to understand how heat pumps can indeed play a role to economically heat homes in cold weather conditions. Next slide, please. So given the regional variations of climate, electricity, and energy costs, it's important to understand the actual performance of heat pumps in Canadian climatic conditions so we can realistically set and achieve our goals for energy efficiency. Next slide, please. And as many folks previous to me have already spoken about, when considering technology, single capacity units are not ideal for cold climates. So, and it's this technology that the traditional test procedures previously used were developed. Next slide, please. So if variable capacity units are more suited to our conditions, we need a dependable way to characterize actual performance of variable capacity suitable for cold climate conditions to ensure we realize energy savings. Work is underway to develop a test procedure for these units, which uses a load-based test to evaluate performance across a broad range of operating conditions. This procedure allows for a dependable performance comparison for a range of units. Next slide, please. The voluntary test procedure, otherwise often referred to as EXP07, was published in 2019 by the Canadian Standards Association, who manages accredited and non-accredited standards development. Express documents delineated by the EXP are a non-consensus expedited standard. As mentioned, this standard is a load-based test. It's climate-specific test and a rating procedure for heat pumps and air conditioners. The test procedure strives to represent installed performance of variable capacity heat pumps as it measures equipment performance under realistic operation conditions across a broad temperature range for load-based testing, from as low as minus 23 degrees Celsius, which as you can see is important to us, to as high as plus 40 degrees Celsius. This test procedure is out for comment, and stakeholder comments are being received until December 2020. With the objective to have a final edition published by the end of August 2021. Let's stay on this slide, please. To ensure the test procedure achieves its goals, and many of the previous speakers have spoken to this, and in order to characterize actual performance, there is a great deal of work going on to validate what we affectionately refer to as the 3 R's. And those are, first of all, repeatability to ensure that consistent results from test to test occur within the same laboratory, and then also to assure reproducibility for consistent results between laboratories, so from one laboratory to the next, And finally, in terms of field testing and for real-world representation, representativeness is the third R, which we think of as ensuring laboratory results can also represent performance under real-world conditions. Next slide, please. So in terms of recent work, Canada has funded 10 out of a total of 19 laboratory tests recently undertaken in a North American lab in support of work related to repeatability and reproducibility. As you can appreciate, the first two are more lab-based. And for further representativeness, nearly 60 field installations in 3 projects across Canada were undertaken last year in the provinces of British Columbia, Ontario, and Prince Edward Island, which are all in different climate ranges, as I referred to earlier. And so more work is expected to start up this year to test further units in other regions not yet covered, including in the north. Natural Resources Canada has a request for proposal out and expects projects to begin late this year so results can contribute to EXP07's refinement over the next year. We understand there's also extensive work underway in the private sector, and some of the previous speakers have spoken to that. We're collaborating in some of those projects to offer our expertise and perspective and to welcome these contributions into the body of knowledge around this work. One example is within the North American space, work is underway through an informally organized group of like-minded partners. We like to refer to this group as the Coalition of the Willing under the banner of the Heat Pump Coalition. And you can see there are some important partners participating in that work. And so in closing, I just want to reiterate, and I'm very grateful for the opportunity to participate today in this webinar. Collaboration is key. We have found a strong community in this space, and that collaboration is contributing to advancing understanding of what we expect for energy savings from heat pumps for cold climate conditions as they play an increasing role in space heating. While we're working on a number of fronts to better understand the expected energy performance from this technology, we're open to hear from others. Please let us know if you're interested in collaborating with us on this technical work. Next slide, please. I should have advanced a couple of slides, excuse me. So this is the collaboration with the heat pump. And finally, next slide, closing remarks. So thank you very much, everyone, and look forward to the conversation.
Okay, great. Thank you, Kim. That was an excellent overview on how things are progressing here, not just in Canada, but there is some overlap in North America with the heat pump testing. And I will say, from the US perspective, we are participating in the heating load line issues that Kim had flagged. So for us, it's just not about air conditioning. We do acknowledge the fact that the heating load lines have similar issues, just in reverse as the air conditioning. So thank you to the government representatives who have just presented, and now we're going to pivot towards the industry point of view. And I'm pleased to have recruited Rusty Tharp from Goodman, which is a member of the Daikin Group, and as we probably all know, is a major player in the inverter technology globally. And so it is my pleasure to introduce Rusty to give his and his company's and his industry's perspective on the topic of the day. So off to you, Rusty.
Thank you very much, John, and thank you to the others presenters, and for everybody getting up some very early in the morning, some participating late at night. So I thank you for the opportunity to talk about the manufacturer perspective, specifically some of the benefits and challenges of an international alignment. So next slide, please. One of the best benefits from a manufacturer perspective is an aligned test procedure across various nations would help reduce test burden for those manufacturers that do sell products internationally. Testing facilities have always generally been a bottleneck in the new product development process, and the performance testing, specifically for capacity and efficiency, is the majority of the test time that a laboratory is used for. And with all the various MEPS changes and technologies such as controls, refrigerants, and other components that are continually changing, many of the manufacturers' laboratories are already overloaded with testing. And for example, in the United States, we have a lot of pending regulations and refrigerant changes coming up in 2023 to 2025 timeframe. So our laboratories are already very highly used, and anything that we can do to reduce the testing load would be helpful to an OEM. From a marketability perspective, again, with the differences noted in the test procedure today, especially the seasonal calculations, it's very difficult to make a comparison between different products from the different countries. You know, for example, it's difficult to compare a Japanese seasonal efficiency to a US seasonal efficiency or a European seasonal efficiency. And so while there may be some good reasons for the differences in the national test procedures, those differences are a little bit of a technical barrier to trade, and we want to minimize any of those TBTs as time goes on. So as a manufacturer, as we develop these newer, better, more efficient products with inverter-based variable speed, it would be nice to be able to do a single set of testing. And by doing so, the OEMs with these products can bring the newer, better, more efficient products to market globally and expand their use in countries like the US, where the adoption of these better products are less. A third benefit is the performance representation and making it more aligned to what is actually noted. Both Virla and Kimberly from NRCan noted that there's some challenges with taking the existing rating procedures and making it truly representative of how it operates in the field. There's been other changes to some of the test procedures, giving a few examples of those in the DOE Appendix M1, also similar to 210-240. There has been an increase in the duct static for ducted products. I know that the ducted products were not part of the comparison of the report, but that tends to make a comparison to the actual installation a little bit better. There's also some changes in the DOE Appendix M1 versus M that changes the heating loads flow. That was already discussed. Making dehumidification, as was noted previously, actually for Virla's comment on 1230, it's actually 82% at the full load condition and 85% sensible heat ratio. Basically ensuring that there is some dehumidification helps make it more representative of most of the applications. And as Catherine indicated, the CVP, or Controls Verification Procedure, validates the steady state operation. So all of these things have been done to improve the representation. So we like the fact that we're getting a more representative and consistent across manufacturers. These provide a better comparison for typical applications, but we also need to note that not every application has dehumidification. So even in some areas of California, Phoenix, other places in the United States, there's less humidity that has to be removed. So one of the things, just need to keep that in mind, which will be something I'll bring up under the challenges. It should also be noted that these test procedures provide ratings for the equipment itself and doesn't include any losses such as ductwork. From the equipment capabilities perspective, if we make a internationally aligned standard, one of the things that this can do is help enhance the ratings help enhance the applicability of the variable speed products. As noted, the variable speed products today actually are covered under the test procedure, but their full benefits are not fully addressed. With such a modification, we could have a better representation of the energy saving benefits of these variable speed inverter-based products, such as control of humidity, peak load enhancement, etc. So we could take some form of validation that would be loosely based on the AHRI 1230 CVP that Catherine mentioned, or even a new AHRI standard 1380 on demand response, those things could be input into the this new test procedure that would help to provide a equipment capability, show how good these inverter-based products are. So if you will, advance to the next slide. And we'll talk a little bit about some of the challenges from a manufacturer perspective of an internationally aligned standard. As was noted, there's a significant variance in the climates around the world. And ISO very nicely has 3 basic climates, so you can have a rating for each one. But one of the things we note is that the indoor ambient and indoor airflow rate also have a very significant impact. And we want to make sure that there's a way to address the various indoor conditions that are around the world. Typically, Americans, US folks anyway, typically keep set points of different lower setting than other places around the world. Also note that as we work to address heat pumps, as was noted in the NRCan presentation, heat pumps are growing in use based on AHRI publicly available data. Back in 2000, heat pumps were 20% of shipments, and they've nearly doubled in the last 19 years, 2 decades, to 37% in 2019. And so those cold climate applications of heat pumps continue to grow. So, in an ideal world, we have one test procedure that covers all these applications, but to have that procedure cover this huge range of operating conditions would be somewhat of a challenge. Also, from a variable speed perspective, there's a lot of different control options and IoT as that continues to grow. So one of the great aspects about inverter-controlled compressors, as well as fan motors capable of varying airflow, is that they can provide a lot of opportunities for energy savings. There's with the flexibility and multitude of options variable speed equipment provides, it's going to be difficult to have a test method that covers all those. Also, defining from a building load perspective, as noted, there's a lot of different buildings, and no 2 buildings are going to have the same building load, and therefore to have one rating that covers all the different applications and the construction styles that are across the various countries will be a challenge. And it was already discussed a little bit about repeatability and reproducibility. That's one of the manufacturer's biggest concerns about some of the proposed test changes. Ideally, we would like to have the same test procedure across these various countries. And what we have found is that we like the steady state operation because it provides very good, relatively good repeatability, reproducibility. We have a lot of knowledge about that. So we really like the proposed CVP procedure of AHRI 1230, which is, by the way, is based upon a Japanese test procedure. I believe the number is B8616. And so some form of procedure to validate the operation of steady state that is realistic is where we would like to go. At least we think that is a good way of providing some good representation, as well as getting a good repeatability and reproducibility. So those are, I'll just wrap up here with the fact that these are not the only benefits and challenges. I'm sure if you talk to any other manufacturer, they'll come up with a different list. But I do appreciate the opportunity to provide a little bit of insight from a manufacturer's perspective, and look forward very much to working with all the other stakeholders in harmonizing and aligning test requirements, because we think that is a very good effort. So with that, back to you, John.
Okay, thank you, Rusty. That was a very, very good overview of the manufacturer perspective. And obviously, I'm sure the regulators around the world have heard loud and clear the issues that manufacturers face in this area. And I know we all strive to keep the test burden down, while at the same time trying to provide consumers a representative metric and representative energy use when these products get to the field. So I think we, both the government side and the manufacturer side, have the same goals in mind. So I think we're getting there, and I think this webinar has actually shed some light on the commonality that we have here. So now we move to the Q&A session. We're right on schedule, which is good. We've got some questions that have come in, and so I will read some questions off and pass them to whom I think is the right person to handle them. So, so from Jessica's presentation, we had a couple questions come in, and they are in your presentation. You mentioned something important was to account for secondary energy use. So maybe you could tell the webinar what you mean by secondary energy use.
Sure. So secondary energy use is basically processes that use energy that don't directly provide cooling or heating in the air conditioning equipment. So this includes things like defrost, crankcase heat, standby mode, and off mode power. So those things that are using energy without providing a benefit to the building or the space.
Okay, great. And while we still have you, another question for you. Were practical tests done during this research, and could you clarify which SEER performance factor of the country is stringent? I don't know if I got the question exactly right, but maybe you can.
Yeah, so I'm not sure I fully understand the second part. I'll address the first part first. The research that we did was a survey of existing research and test procedures and did not include practical testing. On the SEER question, I'm not sure I completely understand, so we might get a follow-on question, but for some background, we used seasonal efficiency metric kind of generically because all countries use different metrics to set their minimum energy performance standards. So for example, many of the countries we looked at break out seasonal cooling energy and seasonal heating energy performance with separate metrics, although they may use different names. But Japan, for instance, uses an annualized performance factor, which looks at energy use over an entire year. So there's a lot of variation in energy efficiency metrics globally, as well as the minimum requirements for them.
Okay, and then another question I think that follows on to that is we had a question from Ghana, and he asked, what is the difference between AEER, SEER, and CSPF?
Let's see. AER is typically going to be an annualized energy efficiency ratio. So that would be, again, something that looks at an entire year's worth of energy use. SEER is typically a seasonal energy efficiency ratio. And most often, those are going to break down the total cooling energy over the cooling season divided by the cooling output. CSPF, let's see, I'm going to have to remind myself here on that one. I'll have to get back to you on that one. I don't remember off the top of my head what CSPF stands for.
Okay, that's fine.
Okay.
All right, so for Virle, we have a question. Someone wrote in, thank you for the great overview of issues, and a question on clarification for the European case and the 3 proposed tiers to improve the testing. The question is, will these be mandatory testing requirements for eco-design and labeling, or will they be applied to eco-design labeling after the review in 2029?
Well, thank you, by the way, sorry. Well, this is just a proposal at this point, so still under discussion, but the proposal that we made was to have the mandatory tier 2, so meaning that the products would need to be tested with the independent testing method, which means that the compressor fan is unfixed and that the controls are reacting to this load. So it would be mandatory before the review. But of course, I mean, in our working group meeting that we had on the 18th of June, many voices were heard, and some of those voices asked to have a review before the second tier. So it will depend a bit on the feedback that we get in the next coming month, I think.
Okay, great. We have another question, I think probably targeted towards Virle and Kim, and that is, do you have value of the relative market of heat pumps versus air conditioners in terms of energy consumed and the volume of HFC?
Not out of the top of my head, I would say. Possibly there is some data available in our studies. So the studies that we do to as a preparation for setting requirements. And these studies are available on our website. This is Circa BC. If you Google it, you will come to it. If the person in question wants to have a look at the studies, they can send me an email or go through TruSeed, and I can send the link to that website for more information.
Okay, great. Kim, did you have anything on that one?
Hey, John, I would echo exactly what you have said. I don't think I can answer that question here, but I'd be happy to take the question away and return with a response to the requester.
Okay, great.
Yep.
Okay, I got one for Catherine now. So the question is the CVP checked for high, mid, and low thermal loads?
So the way that the CVP is actually applied is a bit more involved than the slide might have made it out to seem. So it could be used at all test points. So IER has 4 test points, 25%, 50%, 75%, and 100%. It could be used at all of those load points. But whether it would need to be in all cases, all of the intricacies of that, you'll have to wait until 1230 is published.
Okay, so stay tuned for how that develops. Okay, one for Kim here. In Canada, the Energy Star is different for all the 6 climate zones? That's a question. And if so, how is this properly communicated to the consumers at large?
So the Energy Star program that's administered in Canada is largely for most equipment, not entirely, but most equipment is largely based on US criteria. So the criteria that are used for the US Energy Star would be what is applied to in Canada. As I said, there's one exception, but it's not a heat pump or air conditioner piece of equipment. So the climate zones I don't think are accounted for in the Energy Star work, but John, maybe you can correct me on that. I'm not sure that that's the case.
Right, so it's currently not the case. So
yeah.
But there is a revision going on as we speak for Energy Star, and I know we're doing a lot of work and testing in that area to better look at that. And I know Canada and the US are both involved heavily in that development. So stay tuned for that. And I will say that as we move forward with Energy Star revisions, this notion of CVP is going to be one that is going to be thought about as it applies to other technologies, not just heat. It's going to be everything that has variable speed. So okay, I've got some more questions here. How about one for Rusty? So the question is, what are the benefits of more consistent terminology from the manufacturer's perspective, and how can we improve that?
Well, thank you, John. And one of the best benefits is to make sure that we're aligned in how we interpret the test procedure It also helps to make sure that there's a level playing field as we go from manufacturer to manufacturer, country to country, that there's consistent way of rating the products so that there's a good comparison for consumers to make the most appropriate choice. So that's really one of the best benefits of having a consistent terminology. Improving the situation is just like several of the Department of Energy negotiated rulemakings and other activities and standards development processes. We get all the stakeholders in the room and make sure that we hammer out the details of the language that is used to make sure that it is consistent amongst the various standards and amongst the countries. Hopefully that answers the question.
Yeah, well, that's great. So this one just came in. I'm not sure who wants to take it because I think several of us could probably field this one. But the question is, what is the difference between SEER results from the lab test and real field performance in hot and humid climates? Are the performance benefits from fixed speed to inverter type AC shown in labs also shown in the field? And I guess this is kind of gets to the whole crux of what we're looking at here. So I don't know who wants to take that, but just jump right in.
Well, Rusty will start, and hopefully some of the others will chime in. One of Rusty's opinion is that it is extremely difficult to have one test procedure that fully represents every application in the field. That, as was discussed previously, there's a variety of different actual building loads. There's a lot of different climate conditions, but to be specific to the question as far as the hot and humid climates, I personally live in Houston, Texas, and it does get warm and humid here in the Gulf Coast region. And generally speaking, a product with a higher SEER in a laboratory will have a lower energy consumption in the field. So generally speaking, that's true, but to accurately get to each individual application, one of the benefits of making a new test procedure would possibly be coming up with a method of providing some better individual applications as you go from a hot humid to a hot dry to a mild climate to a marine climate to a very cold climate. So hopefully that answers the question. Let some other panelists weigh in.
It's Kim Curran speaking from Natural Resources Canada. I don't think I can answer the question specifically, but I just want to raise something that John, you alluded to as well. I mean, that is really the crux of what we're speaking about here. And Rusty, thanks for the manufacturer's perspective. I think there's a few perspectives to keep in mind, and it's all going to depend on what you want to use the test procedure for. If you're trying to set up, kind of just a ranking of equipment, minimizing the number of test points is okay. But if you're trying to actually save energy and predict what those energy savings will be and cost out what that energy savings will be for utilities, for rebate programs, for a number of things, I think then a broader perspective is required. So it's really kind of trying to balance out the two. And I'm not answering the question, but I think what the question is trying to raise is there are differences in perspectives for how you want to use information. And in this case, it would be more detailed with the hot and humid conditions needing to be accounted for in a test procedure. I hope that helps the conversation.
Thanks, Kim. Anyone else, Catherine or Jessica?
Sure, this is Jessica DeWitt. I just have one more thing to add. I think I in agreement with what Rusty said. Generally, a piece of equipment with a lower SEER is going to use less energy in the field. I think traditionally, a SEER rating for like a fixed capacity equipment was somewhat representative. I think one of the challenges with variable capacity equipment and how equipment is changing is that the test procedures aren't necessarily capturing the effects of control systems and variability or variation in current variable capacity equipment. So I think there might be less correlation now between SEER results and specific field operation. And I think that's where there's room for further research, is that we're trying to understand exactly what that variation is and how to address it in a test procedure.
Okay, and Jessica, I think you said lower SEER, lower energy, but I think you meant to say higher SEER.
Sorry,
lower
yes.
energy. Okay.
Higher SEER, lower energy. Thank you.
Great. Catherine, anything to add, or we can move to the next question?
Yeah, I think the other panelists more or less covered everything, and I would echo and agree with what Jessica just mentioned about right now with the SEER reading, and it's one that I'm less familiar with. We're certainly testing the hardware, but we want to make sure that we're also ensuring that the software is working as it should.
Okay, great. So one here for, I think, Relay, you can probably address this the best, since I think your testing is kind of out in front of the rest of us. But the question is, are you tracking the hybrid approaches being tested as part of the Global Cooling Prize, given that the units will be tested in lab using Indian test method, and it's the iSEER, adapted from ISO 5151, lab simulated year-round climate and field test? How might these results inform what you're doing?
To be honest, I don't know. I'm not even sure that I understand the question. I'm sorry.
Okay. Let's see what else we have.
I'm really sorry for that.
No, that's okay. It's okay. So here's one that kind of looks at things from the opposite sort of point of view. And so this is for the group, and anyone can jump in. What is the likely impact of not improving the part load testing of inverter ACs? So what are the pitfalls if we don't do anything? Who would like to jump in first?
Well, Rusty will jump in and give one from a manufacturer perspective, as we are interested in promulgating the use and acceptance of variable speed products. The one thing we need to remember is that the majority of air conditioning and heating operation is at part load. And there's been an emphasis on full load for a long time. And obviously we need to consider all stakeholder input, right? So full load and peak load is a very important aspect for utility companies. But the reality is, for most consumers, most of the energy consumption is at a part load condition. So by not improving part load testing, then we're not fully showing the full benefit of the inverter-based products. So I think it's important for us to have a better test procedure that more accurately shows the part load performance of these inverter-based products. So that's my 2 cents worth.
And so this is John, so maybe I'll answer this one too, because I think it's something that we find is very important, in that you're able to compare, at least in the US, right? There's many different AC products that I kind of demonstrated in one of my slides that are competing for the same market, and that the fact of the matter is if the test procedure isn't representative, consumers who are making choices between these different technologies will not have the right information to make the best decision. And so what gets installed may not be the best option, because they didn't have the appropriate and the correct information in terms of the rating that came out of the test method. So I think that's something that's very important that we need to keep in mind. Did anyone else want to jump in?
Hi, John. It's Kim. I would just echo what both you and Rusty said. I think it's really true. We need to understand how these technologies fit and make sure consumers are aware. I would also add that even utilities, while most of the conversation for utilities tends to be peak load, utilities are also worried about actual kind of energy savings, because those accumulate and contribute to where the peak sits. So I think even when you're at part load, the utilities will be interested in understanding that. Thanks very much.
And Rusty, if it's okay, we'll throw in one more comment to the point that John made. When consumers are making these decisions, the reality is most air conditioners and heat pumps last for at least a decade or two. So the decisions that a consumer makes impacts the energy consumption for the next 10, 15, 20 years. So it's important for us to have a good representation of the performance at those part load conditions for the consumer to make that comparison on.
Yeah, that's thanks, Rusty. That is something to keep in mind. These are long-lasting decisions and will impact for decades. So anyone else on the panel want to give one last input to that question before we conclude? Okay. So keeping on schedule, we're heading towards the bottom of the hour here. And so we'll move to the conclusion. I, again, want to thank all of our panelists. And I think this has been obviously a very important issue. And we had, what, 450 people register, and at peak, it looked like we had over 200 folks who attended. So clearly a very important issue globally. I think what we've heard today is that there's work to be done moving forward in this area. And I think we've heard from government representatives as well as industry that it's something that we can work together on, and we can get to a place where it's a mutually beneficial path forward in terms of test methods. And here you could see on the slide, we're going to follow up with some FAQs. You could see the websites here. And please let us know as we go through time. This, just like our testing, this could be dynamic, where we have follow-up webinars and continue to follow the progress in this area. And so if you go to the next slide. Okay, so the real reason we dragged you all out to this webinar. Okay, so part two, yes. This project we talked about today was the first in maybe a series of projects, but we currently have a tender out for phase 2 of this project. And you could see circled here, there is a web link you can click and you can request these tender documents for those consultants who might wish to bid on this next phase of the project. So phase 2 is going to get really into the details of the testing and at some point include some round robin testing. Just to let you know, in the 4E perspective, we have heavy involvement from the Asian countries, most of which produce this equipment, and so they are definitely very interested and involved in this project. And phase 2, of course, is going to be very important because this is where we're going to attack the problems that were identified and the issues and the test methods that we've seen to date. And so the next phase of this is really going to get at moving forward and how we can harmonize these test methods globally. And so anyone who has interest, you could see here how you can bid on this project. We hope to get lots of good bids for us to make selections. We do want to kick this project off as soon as possible. We understand how important getting ahead of this is, as more and more air conditioners are shipped around the world, we want to get ahead of the issues in the testing and hopefully get efficient product on the market as soon as possible. And so with that, I will conclude my part of the webinar and maybe turn it back to Emily for closing remarks from the IEA.
Thank you, John, and thank you for all our panelists for a great webinar, putting up with our technical glitches. I really appreciate it, and we've received a lot of questions that we didn't get time to answer, so I think together we'll put together a Q&A and we'll send that around to all the participants so we can get a chance to answer some of more of your questions. But again, thank you everyone. Thank you everyone else, for all the audience, for listening, and I wish you a lovely day. Thank you very much.